Friday, May 10th. Hi, Josh. How you doing?
Hi, Eric. I'm doing well. I want to talk today about sort of really focused science-related health things. I wanted to cover osteoporosis.
Very good.
Just because it's so important for us, and it is a topic that I cover in my classes, so I'm pretty familiar with it.
Why do you cover it in your classes?
Why do I cover it in my classes?
Why is it a regular thing that you cover?
So I teach human evolution and I teach Darwinian medicine, and Darwinian medicine is sort of a subset of human evolution as a topic. And both of them, bones are everything. So if you're a paleontologist, what you dig up is bones, and it's our biggest way to look at the health of ancient peoples is to look at their bones and look how they've developed and look how they've changed. And one of the things that we see in modern humans is osteoporosis, and we don't see that in earlier humans. Now, a lot of them didn't live past age 50, so osteoporosis is usually associated with menopause. And so if you don't live past age 50 as a woman, you're not going to get osteoporosis. But enough did that we can see that they still didn't get osteoporosis. So this is purely a disease of the modern world.
So you teach this as you know, just in due course, because evolutionarily it's a thing.
It's a thing. No, it's absolutely a thing. How our bones develop is the focus of a lot of paleontology, biology, because that's what we know. Nothing else survived. We don't have a lot to go on except for the bones.
Fascinating. I had no idea that osteoporosis was a regular course of studies in.
Well, it's not a course of studies, but I have a class on it. I have a lecture on it, and it relates to other things, just as teeth, right? The other thing we have a lot of are our particular, really specialized bones, our teeth, and they're what survive as well. And so we talk about teeth a lot. Mm-hmm. And so these are major things to think about, and how bones form and how they look and how they develop. And so it is definitely something I look into.
I hope that for people who have been your students, these questions that I'm asking are not boring, but I've never actually sat in your classes. We've only spoken informally.
Students don't ask why you teach things.
Okay, very good.
They just want to know what you're teaching.
So that I can pass the test.
Pass the test, and they figure that's why you're the teacher.
Right.
And it to a lot of them, I think, would be impertinent. Sometimes it might be. Why are you teaching me this? It's kind of not a great question. From you, it's a great question. From students, I don't necessarily need that question all the time.
All right.
So anyway, in my Darwinian medicine class, the focus of that class is to compare how we live today with how we used to live, mostly as hunter-gatherers, how we evolved, how our bodies and minds evolved, and the difference between our, cubicle living, fast food eating reality today. And one of the real differences is osteoporosis. As I was mentioning, hunter-gatherers do not have this problem. Modern humans do. And so it's fun to look at what those differences are and why we might get into it. So first of all, what causes osteoporosis? Osteoporosis is thinning of the bone, particularly the structural fibers that are sort of like the cables of a bridge that hold everything together, that support the bone. When they thin, they can be replaced, but once a fiber has been eliminated, it can no longer be replaced. And so you go from a somewhat porous, fibrous inside of a bone, particularly at the ends, particularly at the joints, to something that has lots of holes in it because it's lost those fibers. The fibers no longer cross that space.
They actually disappear.
So osteobone, porosity, pores. So you actually develop holes in your bone, mostly on the inside. You wouldn't see it from the outside. You might notice a little bit of a pitted, but I don't think much of that. It's still going to look smooth on the outside, but the inside of the bone is going to be almost hollow and thin. Yeah, so it starts becoming eggshell-like, and it's super dangerous. Not just because your bones are weaker, which is going to lower your activity rates, which is also going to lower all of your exercise and such like that, but it will get thin enough that the bones can break on their own. So they now think that, for example, one of the leading indicators of mortality in women is hip fracture, and that this might not happen from a fall, but just walking along. Because if you think of the way the femoral head comes into the hip socket, right, it makes a right angle turn. And if that isn't very, very thick bone and really, really strong, that right angle turn where the hip socket is coming in, the femoral head just breaks off.
For those who are not sitting and looking at me, I have been cringing for the past
Sorry.
5 seconds.
I don't mean to
No. You have to say these
that.
things. Forgive me for this reaction.
I'm trying to say it sort of clinically and not get into the details of how horrible that would be. Yeah. So there's often double hip fractures. So you break one hip as you're walking, which causes you to fall over on the other side. Oh. And then the impact on that right angle head also causes another snap.
So that's, osteoporosis can be terrible.
Absolutely terrible. Any bone can break, but it's usually the hips that go, and that's where the most stress as bipeds. We evolved to be bipeds very, very quickly, and so there's a lot of compromises that were made in our evolutionary history. We only did it in about maybe 1 million years, which is not a long time for evolution. And then we kept it. We've been bipeds for 6 million years, and we've improved a lot of the pieces, but it's still not that long for evolution. Just like our lower backs ache all the time because we evolved as quadrupeds and turned into bipeds very quickly. There was some compromises made in structure and strength. The same thing is particularly true of the hips because as bipeds, we put a lot of stress on that spot. And so it doesn't hold itself together. And so bones are made by a kind of cell called osteoblasts. So blast just meaning cell, essentially. So bone cells. Bone cells make bones, and they are stimulated by estrogen. And so estrogen tells osteoblasts to take calcium and turn it into the calcium phosphate bone material. And so osteoblasts go along making this scaffolding. So they can follow an existing fiber and make it thicker. They can take the outer core of that bone and resurface it and make it thicker as well. But they can't replace something if it's not there. If there's no bone there at all, there's nowhere for them to crawl. So they crawl along bone, fixing it as they go. And if there's no bone there, that's why they can't improve it once you've lost it. So the key thing is keeping your bone density and not losing it, because you can always thicken things a little, but you can't replace it once it's gone. And all of this has to do with early lifestyle, how you were as a child, and getting your bones thick ahead of time early on. So anyway,
you're saying that getting your bones thick early on is the key to not losing the bone density later on.
Yeah. So what really matters is puberty, and it matters for menopause.
And what about those of us who are past puberty but not yet at menopause?
We'll get there. There's still things you can do.
Okay.
But the most important time is puberty.
Okay.
Absolutely. You are filled with anabolic steroids. They're building your muscle mass. They're building your bone density. It's when you have the most estrogen in your life. So estrogen tells your bones to get thicker. By communicating with the osteoblasts. The osteoblasts take the calcium and they lay it down. Now you might say, but I am a man. I have testosterone, not estrogen. Well, what happens is testosterone is turned into estrogen in the bones. So men maintain their estrogen in their bones because of their testosterone. Men have a decline in testosterone over life, but it is not the plummet that happens to the estrogen in women in menopause. And so that's why men's bones do get weaker with age, but women's bones get weaker really fast.
Interesting.
In really about a year time. Suddenly they're losing all that estrogen.
Wow.
And so they go off a cliff in terms of bone density. And that's why a lot of people recommend estrogen replacement. It's not necessarily for everyone, but it's something that can maintain that bone density and really help you live a better and longer life because your hips don't break and you have more possibility of activities. So back to sort of how this is all working. So the osteoblasts make bone, and then there's something called osteoclasts, which remove bone. So like iconoclasm was destruction of the icons. Osteoclasts are destruction of the bones. So you've got the bone cells and the bone destroyers. And so the bone destroyers are what go in and actually remove things so that the osteoblasts can go in and fix them. So every time you exercise or you put any stress on a bone, there's tiny little breaking of those fibers. Bone is made up of a mixture of collagen fibers with the mineralization sort of around it and over it. And so when those collagen fibers snap due to pressure put on it from actually pulling on a muscle, the osteoclasts go and they start removing that broken portion of it. Imagine a rope that started to fray. So some of those little fibers start to break, but the rope is still there. And so the osteoclast will get rid of all that frayed material, and the osteoblast will go and make a new rope, essentially. But if the rope is gone, there's nothing to work with. And so this is why it's really important to not lose too much, because you can't rebuild it again later. So there's a normal process of osteoclasts breaking things down, osteoblasts repairing them, making them thicker, rebuilding it, making it stronger. But what happens when you're missing the estrogen, then you have more osteoclasts than osteoblasts, and you just start reducing your overall bone structure. All over your body, the osteoclasts are now outnumbering the osteoblasts, and everything starts getting thinner and weaker. And so this happens to everyone, but particularly at menopause. And the reason it happens to us, unlike other creatures out there, so this is sort of the interesting evolutionary side of it, is one, we are so evolved to never have anything extra. Most animals don't want to have anything extra. It's extra costs. But we are super evolved for efficiency. That's why we became bipeds. We didn't become bipeds to become the fastest. We became bipeds to become the most efficient. To get from point A to point B costs us the least calories, really, of any large animal. Just walking slowly to get there, maybe even a slow jog. This is how we can kill things, by just chasing them down, because you take more energy to get from one place to the next. So anytime we sit still, we delete our muscles, because muscles are energy expensive. And we start deleting our bones as well. So anytime you're not moving, you're going to get rid of any extra cost you can get rid of. You want to reduce your caloric load, because all you want to do is maximize calories to keep your brain alive. Evolutionarily speaking.
Again, about the big brain. It's
all about the big brain. Yeah, exactly. And your brain needs a constant load of calcium to work. It's how nerves work. And so
calcium makes bone, and calcium makes brain and nerves.
Yeah, basically. So nerves send what people call it electrical signals, but it's actually a depolarization across a membrane of charged ions. And one of those ions is calcium. And so it's these calcium ions moving across the membrane is what send nerve signals. Calcium ions flooding between the nerves is what is part of the signal between nerves. So when calcium ions flood between cells, it causes depolarization and a signal to continue. If your calcium levels get too high or too low, the whole system breaks down. The first things you start to notice things like muscle cramps and stuff like that. But if you don't have enough calcium in your brain, you're just dead within seconds, really. There are nerve toxins that flood you with calcium, also dead within seconds. So calcium has to maintain within a very narrow region. So this is where you start to get into sort of the dietary side of things. You need calcium in your diet, because if you don't have enough calcium intake, the calcium has to come from somewhere. And so if you don't have calcium in your diet, it comes from your bones. And so your body starts thinning out the bones. And so your body is programmed to just go right to the bones, try and thin them out as much as possible so we don't have to carry around that weight. Again, for efficiency, again, to keep that big brain going. But it's never going to let the blood levels of calcium get below a certain level. So even skipping calcium for a short amount of time, this is in short periods of time, you'll start thinning your bones right away. So if you don't exercise and you don't have calcium in your diet, even over a couple of days, you're going to get thinner bones. So you need to keep that calcium coming in constantly. You need to exercise constantly to maintain that cycle of refinishing the bones and keep those osteoblasts making new bones. Anytime you're not exercising, the osteoclasts are just thinning the bones, sending those calcium ions into your blood, keeping your brain working, but making you overall weaker. And it's doing this in the name of efficiency, because less bones means less stuff to carry around. It's easier to get from point A to point B, so we can gain more calories. So evolution just wants you to sit still and get fat. That's the only thing it wants, and then make babies. All right, 2 things. Sit still, make fat, and make babies. 3 things. All right, anyway, you're programmed to like these things. You're not programmed to do the things you need to do, because it figured being hungry would get you to do that. right? So evolution was designed to make you sit still as much as possible and then get up and go find some food when you were hungry.
Evolution did not think of canned food, microwave food,
Refrigerators, all of that.
all of it.
All of that. Yeah. No, you should be, walking 6 miles to get your food and then 6 miles to come back. And then you have to like spend an hour or two pounding and chopping it and then you get to eat it.
And we think it's nice to take a little walk after dinner.
Yeah, exactly. And you should chew on your food for hours and hours and hours because it's so tough and difficult to get through, which goes back to the bones. Our bones are absolutely designed for all of these things. I mentioned it before that a 19th century strongman could bite through an iron spike. They're not genetically different from it. They're just using those bones. And so when you use bones, they get thicker jaws. There's a sort of stereotype that the thick jaw is manly. We've lost that because of our lack of chewing. Essentially, our jaws have gotten thinner. Our teeth have gotten smaller. We didn't need to used to have our wisdom teeth removed. We had enough room for them. They would come in. They were nice and thick, and you could just bite through anything. And that was simply because of the differences in use. So the same way our overall skeleton gets thinner when we don't use it. Our teeth are a special case of bones. The only exposed bone, but they fall into the same set of categories. When you're young and you're chewing, particularly in puberty, you're going to be strengthening everything. Everything's going to get thicker and larger amounts of bone, and it will be reduced if you don't do these things. And once it's lost, there's no going back. And it's particularly true of the teeth. You can't remodel your teeth after they've formed themselves. So this is a really, really important system. So first of all, you need to keep your calcium intake. You need to have exercise so that you're always strengthening your bones, because your bones will just go away when you don't do these things. And you also need vitamin D. So vitamin D we get from sunlight. It can be also, people put it in milk products, etc. But it's naturally coming from sunlight interacting with proteins that are already in our foods, and it modifies them. The vitamin D then actually is what tells our intestine to take up calcium. So that's what the vitamin D is doing. If you don't have vitamin D, you can't get the calcium intake, and again, you very quickly start losing bone density.
Vitamin D basically activates your body to be able to take in calcium. So
exactly.
You need vitamin D in addition to dietary calcium of some form.
Exactly. And there's a lot of debate on this. Some people say the calcium in green leafy vegetables is easier to uptake than the calcium in milk. Obviously, the calcium in milk is much higher percentage, but it's difficult for us to absorb, for some people more than others. So there's some debate on that, but regardless of sources, you absolutely need the calcium and you need the vitamin D or you can't use it.
What a coincidence, they put both in milk.
Exactly. Well, there was a reason for it. But hunter-gatherers wouldn't have had this part. They would just eat the whole eggshell and all. If they was a bird with bones in it, they would just chew up the bones. That's where they got their calcium. They didn't drink milk. That wasn't an option. So they were getting it through their diet, and they never had a lack of it, just because it was everywhere. And they always were outside, so they never had a lack of vitamin D.
That didn't go away very long ago. I remember my father's sister, my aunt, who would just chew up the chicken bones and eat the entire apple and all that stuff.
Yeah.
That was just a generation or two ago.
My father worked in a law firm in England where the people in England had been in Shanghai when the Japanese came in and took over the city. And the English prisoners, I guess, I don't know what you call like children who are being kept in a concentration camp, but they're not as badly off as the Chinese children being kept in wherever they are. They would be allowed to leave the camp and forage for garbage. And their main food that they were really hunting for was eggshells, because each eggshell had some protein left on it. And so this lawyer working in a law firm in England was talking about his childhood scavenging eggshells from garbage cans as the way he got through the war.
And they would eat the eggshells?
Eat the whole eggshell. Yeah, there's a lot of food in an eggshell. So yeah, we've been ignoring a lot of things that we are well evolved to do, and things that seem really nasty become tasty and delicious under the right circumstances.
Wow.
So anyway, yeah, we need a constant form of calcium. The people who didn't eat those eggshells, those boys would not have developed bones properly. I assume there were girls out there too, but I sort of, in my head, I picture a kind of Neverland with the lost boys running around through the streets. But I'm sure it was mixed group. Had to be. And then what happens is, I mentioned puberty. So when you're going through puberty, estrogen and testosterone, these are anabolic steroids. They build muscle density, but they also build bone density. And so this is the primary time when you get your body ready for future bone strength.
How do we feed the needs of that moment?
Weight training, exercise, anything that puts stress on the bones using muscles is going to make them thicker.
During puberty or start in prepubescence?
Well, the habits should start in prepubescence, but
weight training.
Anything that puts stress on the bones, a push-up or a handstand or anything that's actually doing it. Strangely, the two things that later in life really seem to help prevent against osteoporosis are literally weight training or gardening. And if you think about gardening, it's awfully similar in some ways to what we did as hunter-gatherers. The kneeling, the pulling, all of these things bending down, standing up, exactly.
Things up, pulling,
exactly.
Pushing, digging.
Exactly. So it doesn't need to be lifting weights. It just needs to be this kind of active movement that's putting pressure and stress on the bones.
So basically, during puberty, doing things that you would never want to
do. For most people in puberty. Yeah. I mean, most girls and boys are not going to be wanting to
spend 20 minutes a day lifting weights.
Or gardening. Yeah, it actually might be easier to get them to lift weights. But anyway, so these are the things that in your life can really help maintain bone density, is that kind of movement.
And foods?
So the foods are the ones that are rich in calcium, and things that can maintain vitamin D. So either exposure outside or actually just taking a supplement. I'm agnostic on sunlight. A lot of people used to be in favor of it. People are now generally against it. We do know that it ages the skin and can cause skin cancers. However, skin cancers have gone up as we've gone inside. Farmers didn't used to get skin cancers at the same rate that our cubicle living world does today. So there's a problem with the way we're thinking about this. I'm not sure what it is. I suspect it has to do with sunburn.
Do lotions and sunblocks stop the effect of vitamin D from sunlight?
That's an interesting question. I don't think they stop the effect of vitamin D. They definitely keep you from burning, but some people think they don't stop a problem of skin cancer either. So it's some people think the rise in skin cancer is due to the lotions. I don't think so. I think it's that what we do is we go inside, and those of us with pale skin, it gets even paler when we spend time inside. Again, our body eliminates anything we're not actively using. So we eliminate the melanin, so we have no protection when we go out in the sun. And the first thing we do when we go out in the sun is we get a sunburn. I think it's the damage that causes the cancer. This is a sort of separate issue, but in many cases, the reason cancers develop is because of damages to some sort of tissue. And so
even if you heal, you might have caused damage that will not be manifest until years later. Exactly. Yeah. So the number of times you've had sunburn as a child correlates strongly to the number of skin cancers you have later in life. And the severity of the sunburn. One really bad sunburn is worse than many summers where you didn't have a bad sunburn. It's really the damage that you see problems with later in life. I think it's true for intestinal cancers as well. I don't want this to promote helicopter parenting. Like, this is.
No.
It makes you feel like, oh my goodness, I need to control
let your kids
every single thing
out
they do
at the beginning of the summer naked, so they get sun and they start to adapt. And they start in April naked, and they go right through the summer barefoot and naked until they're well tanned and healthy by fall, and you take them in again.
So, like you said, the problem is not necessarily the sun exposure. The problem is the damage from the sun.
Right, and It does. Sun will age your skin. You'll get more wrinkles and such. You think of the 40-year-old farmer who looks 70.
I'll live with wrinkles if don't have to deal with cancer.
They don't have as many skin cancers. Exactly. So I think there's probably a balance between too much and too little, as there are in many situations.
You don't have to live in the sun.
But the sun, but we are definitely evolved to take in sunlight and turn it into vitamin D. And this is one of the few cases where there is actually differences between what people call races incorrectly, but people with different amounts of melanin in their skin have a different relationship to sunlight. Obviously, when you have darker skin, you have more protection against sunlight, but you're not going to take in as much vitamin D. So some of these lotions may be actually blocking the vitamin D. I don't know much about that topic, but I know the melanin is. And so that if you were evolved...
The melanin is blocking some of
the vitamin D, absolutely. So evolution doesn't care about skin cancer because that happens later in your life, but evolution does care about forming bones as children.
In other words, you've procreated, so evolution's done with you.
Right, but you do need vitamin D to develop good bones, and if you don't develop good bones, you're not going to be strong enough to reproduce, so evolution cares about that. And so evolution has maximized melanin towards the equator and minimized it further north because of two things, vitamin D and folic acid. So folic acid is needed in pregnancy. Sunlight tends to destroy folic acid, so you need to maximize melanin to protect against the sunlight. But as you start heading north, then you lose sunlight and you need to take in more to get enough vitamin D to develop properly as children. So these things are important, and you have to see where you are in evolution to understand what you're going to need.
And it's fascinating what you're saying, that we, whatever the body isn't using, it's getting rid of. The things that we're using are not necessarily things that we have chosen to use. They're things that we're using without even knowing it. It's from our environment, from where we are.
Absolutely, yeah. We don't think about using sunlight. We just walk around outside, and
but we're
it happens to us.
Parts of our body that have to adjust to that.
Exactly. Yeah.
And that's in whatever, like living in the city.
Yeah.
Does other things too.
And the calcium building bones was so important on our early evolution that we actually didn't just get less melanin, we changed it. Eumelanin is the kind that you see in equatorial regions. We have this sort of more yellow tone to the melanin if you're from a European area. This may be a Neanderthal gene, but not from the Neanderthals in Europe, the Neanderthals in the Middle East, actually. So the pale skin that Europeans have came with the Middle Eastern farmers who brought farming to Europe. The hunter-gatherers from Europe were basically eliminated. The people the Nazis worshipped had dark skin and blue eyes. And the farmers came in with brown skin and pale skin, and we ended up with many Europeans with the blue eyes and the pale skin. And the reason they got pale skin was to allow more calcium in, but they changed the kind of melanin. It's a separate gene, probably from the Neanderthals. Eumelanin actually does better cancer repair. So skin cancers are inhibited by the eumelanin that some people have, and the other kind of melanin actually somewhat encourages skin cancers. So we traded a later in life problem for early calcium uptake to produce good bones early in life. So we were willing to trade off. Yeah, we'll all die of skin cancer when we hit 60, but we can now trade this for stronger bones earlier in life. So this is how important stronger bones are in development. It's something that evolution is really focused on, and it's very, very important for us. Now, there are other ways to train bones that most people don't know about in our kung fu.
So now you're moving towards what we can do after puberty.
Or in puberty, but also after puberty.
Okay.
But so in our kung fu practice, there's the saying that kung fu trains the bones and karate trains the muscles. I think all of the martial arts are going to be training the bones.
Yeah.
But one of the reasons we think about this is it's not just the muscle use that encourages bone formation, but also impacts. And so this is where most health discussions aren't actually going to talk about.
You were saying that impacts on the bone.
On the bones.
Train the bone.
Train the bone. Make them longer. Make them stronger. So the same way that the when one of these small fibers breaks, the osteoclasts go remove the broken part, and then the osteoblasts fix it. The same thing happens when you actually just hit a bone. One bone hitting on another bone, both of those bones are going to be slightly damaged, and then when they're repaired, they're going to be stronger and thicker in response to it. And so this was known obviously within martial arts communities for thousands of years, but it was not well understood by scientists until relatively recently. In the late 90s, I went to a talk at Rutgers where they had people who were working on astronauts. And astronauts have the problem of when you go into space, you don't have any gravity pulling on your bones. Again, as soon as you're not using something, your body gets rid of it. And so astronauts many times will have to be in wheelchairs.
That must be catastrophic to the body. Like losses everywhere.
Losses everywhere, plus a high G environment as you're coming back. Things can be pretty bad. And so they have to go through rehabilitation when they come down. So space is not good for you. And one of the problems of space is the low gravity, eliminating bones. So these guys at Rutgers wanted to know how you make bones stronger, and so they were doing terrible things to goats as ways to strengthen them. They would make stresses on one leg of a goat and then compare it to the other legs of the goat that didn't have those same stresses. So they looked at muscle stresses, and they also took one of those little rubber mallets that you use to check your nerve reflexes and would just hit the goat on the leg for a minute or two each day, and then look at that. And both of these things were able to change the bones of the goats. So it's not just muscle activity, but it's also the impacts on the bones.
And it's not a woo-woo kung fu concept.
Oh, absolutely not. No, you really literally make them bigger.
This is something that science can support.
And interestingly, again, this doesn't get into much of the literature. But in this study from Rutgers, where these were serious scientists doing terrible things to goats and doing really serious work on how bones grow and how they work, was there are two layers to bones. You have the periosteum and the endosteum. So the periosteum and the endosteum. Mm-hmm. The periosteum is the outside core of the bone. Or outside core of the bone, the outside of the bone, and the endosteum is the inside core of the bone. So the endosteum is where these fibers are, where you're often getting the osteoporosis. That's the inside, the center core of the bone. That is what you mainly build in your youth. So that's what you're building when you're a child, when you're in puberty. It's that inner density. And so you can really only build that in your youth, up through the age of, I think it's 20 for girls and maybe 22 for boys. You can build that inner core. But after that, you're mostly done with that outer core. But the periosteum, this part can actually be changed throughout your life. So you won't build that inner density that you can build earlier in your life, but the periosteum you can build by banging your arms into things or through exercise. You're going to build the outer core stronger. Now you can imagine in a bridge, that inner truss work is really the important part of the bridge. But if you just make the outside bars thicker, it will also build some strength. So you can build strength later in life. You can build the outer bone density, but that outer part is mostly fibrous. It's layers of collagen and reticular fibers. It's not as solid as that inner portions are, and so it responds more quickly. So if you say bumped your arm into a piece of wood every day for a week. At the end of the week, you would notice a raised bump on your arm. Some of that would be the outer tissue that's responding, but some of that's the bone itself, these fibrous collagen fibers are actually building up. And it's not as hard as inner bone, but it is part of the bone.
It's there.
And again, it can happen in very real time, not something that happens over 10 years, but can happen over a matter of a week or so.
But also could be lost.
And cultivate could be lost as quickly. And so then that lumpy area of soft bone would gradually become mineralized over time and become harder bone, but it would still be on the outside. So the the general sort of set of stages would be this softer collagen region on the outside of the bone that would then getting denser.
What you're saying is that bones react as skin does, and like if you get a callus from a use area, repeated use area, you're also going to have that on bone.
Yeah, exactly. No, very, very, very true. And that's that would be more of the outside than the inside. The inside, you build up when you're younger, but that sort of callousing effect that you're describing would be true of everyone's bones and throughout your life.
So then, if we are expecting that the hips would be a weak area, we could work on improving the strength of the hips.
Yeah, anything that bounces up and down on the hips, but you can't just go right into it, particularly later in life. If you start putting stresses on these bones and there's some damage to them and you don't have enough osteoblasts, you only have osteoclasts, the osteoclasts are going to go remove that damage, but nothing is going to get built. So, if you are a woman and you've already gone through menopause and you want to start building bone, you're going to have to take it very, very slowly. And you might want to match it to added estrogen, because then you can actually rebuild that bone.
So added estrogen will increase the number of osteoblasts.
Yes, exactly.
Is there a dietary way to promote the production of osteoblasts that does not involve?
I don't know of one. I don't know if anyone knows of one. Mostly it's all about keeping your calcium levels high, because again, this is done in real time.
So if you were going to do that, if you were going to undertake a regimen of slowly increasing exercise and estrogen, that's something you would need to do that concurrently, continuously, right? Continuously,
yeah. And otherwise it'll quickly be lost. And you might consider a calcium supplement depending on your diet. You'd want to be careful with that sort of thing.
Once you start this program,
consult a doctor.
Yes, of course. I'm not coming out. I'm just saying that what I'm thinking through is that this kind of a thing could make real changes, but then were you to stop, those changes would literally most of them would just go away.
They will go away, yeah. And your body's designed to make them go away. But it's just like any other exercise. When you build muscle, if you stop exercising, you're going to lose that muscle again.
Yeah.
And so all of these things are directly linked. Yeah, there's no easy solution. Calcium supplements just provide more calcium, but if you're not using that calcium, it doesn't help you at all. It's just going to make you constipated, essentially. So you can't just have a diet that's going to cure your problem.
What else?
But the diet can cause the problem. If you don't have enough calcium, you won't be able to build the bone.
What else will help calcium absorption other than, vitamin D in the sun? I guess vitamin D in supplements.
Vitamin D in supplements, but also, thinking about the stages of your life. So getting those bones dense early in your life so you have them later in your life. Also pregnancy. When you are pregnant and breastfeeding, you're losing a lot of calcium. You're making the baby's bones, and then you're giving milk to the babies. Again, this is a time when you're going to start drawing down your own bones. So you need calcium supplements at this time, or your bones are going to get weaker. I've heard a saying that for every baby you lose a tooth, so you'll actually start losing the jaw bones, because that's some of the stuff that responds quickly to lack of calcium. Is your jaw is going to change some of the fastest, because one, it's the most important, right? If you can't eat, you can't do anything. And so evolution reconfigures your jaw faster than other places. And so it responds to changes in hormones very, very quickly. And so during pregnancy, your estrogen is pretty high. So if you can maintain exercise and maintain calcium, you're not going to have so many problems. But you will very quickly, if you're just eating soft foods and you're not getting enough calcium, and you're sitting around because you're pregnant and you feel like you absolutely deserve it, which you do, you're going to start getting losing bone density, and you're likely to lose a tooth, because the roots of the tooth are still, they're still alive, and so they're going to lose material, and the bone around it, even more importantly, is the teeth are going to get loose in the sockets because the bone starts shrinking around them. And so this is another way that women have a difficult time, and just because of the stages of their life are going to impact their bones significantly. But if you keep in mind that estrogen is there in high amounts when you're pregnant, you can, using diet and exercise, keep those calcium levels high and keep your bone density up, so you don't lose teeth and bones, etc., while you're pregnant. So you really have to think about every stage in life like that: puberty, pregnancy, menopause, etc. This is a issue, obviously, that I'm talking about for women in particular, but these things are true for men as well. That you need to exercise during puberty to get that bone density up, and then as bone density goes down as you age, you're losing testosterone, so you're losing the estrogen in your bones, so you don't make as many bones. Same problem, not as many osteoblasts. You need to maintain exercise. And again, it has to be paired with calcium uptake, vitamin D, calcium levels. Calcium is just really weird thing that this ion is involved in so many parts of your brain and nervous system. You really need to maintain levels second to second, and so your bones are just seen as a reservoir for this. And so you really can start drawing down bones instantly. As soon as you need it elsewhere in your body, if it's not coming from your diet.
But I mean, shouldn't a good supplement that has both vitamin D and calcium help this be maintained without bone loss?
Yes.
Combined with exercise.
Yeah. Without the exercise, it won't do anything.
Yeah.
It'll just pass right through you. You need all of these portions to it.
You literally need to stress your body in order to cause it to rebuild itself.
Absolutely. And other things make it worse. So cigarettes inhibit calcium uptake. I was just thinking about, slightly off topic, but the calcium ions in your brain are often the source of damage during a stroke, for example. Because part of what they do is they start leaking through membranes, causing further depolarization of the membranes. And then once they go through the membranes, they start signaling these enzymes that destroy the membranes themselves. So they start signaling these phospholipases. So your membranes are phospholipid bilayers. They're basically like a soap bubble. Cell membranes form themselves even if you're not alive. They'll just make themselves. And so they're literally like a kind of like a soap bubble. And these lipases go and just destroy that soap bubble. So everything in the cell comes leaking out.
You're saying this is signaled by calcium ions leaking out erroneously.
So if you have too much calcium just floating around in the liquid or outside the cells, they'll start being pulled into the cells. And when they get pulled into the cells and they reach too high a level, they'll signal the destruction of the cell membrane, thus releasing more calcium. And so this is part of the damage cycle caused once you have damage in your brain. The calcium ions themselves basically delete the damaged areas. So they end up being protective sort of in the long run, in that the calcium ions, because they signal muscle contractions, are going to signal vasoconstriction. And so you're not going to have as much blood flow to the area. So it's not going to take those calcium ions that are now destroying all the nerves in this particular area are now confined. And so you end up confining this destruction, but also deleting all the nerves involved. Whatever was wrong with them, they're now all just gone.
Close the bulkheads in that
Exactly.
area.
I just seal off the bulkheads and let it all die. And so that's what was happening when a stroke happens. A lot of that tissue probably can be saved if you stop this sort of domino effect of destruction. But it is actually there for a reason, and that's something that we need to think about in the way we treat neurological disorders, is understanding what needs to be prevented, because it's a sort of cascade of damage, and understand what needs to be allowed, because it's part of your body's defense mechanism, essentially. So anyway, calcium is tremendously important. It's not just the bones, but try to give you an idea of why this is a second-to-second problem, where if your calcium levels drop even a tiny bit, you're immediately siphoning it up for the rest of your body. And you're never going to allow your calcium levels to drop. You will turn to jello and dissolve all your bones before your calcium levels drop, because you're just going to maintain that constantly.
Without the right calcium levels, you're dead immediately. Without the right calcium levels in your bones, it could take a while, and you can fix that maybe.
Yeah. And there are supplemental hormones that can actually help with that. So, for example, calcitonin takes the calcium out of your blood system and puts it in your bones. But if the osteoblasts aren't getting the correct signals because you're not exercising, that won't work very well. If there isn't enough calcium in your blood, the calcitonin won't do anything. So all of these pieces need to be part of the puzzle for the strength to happen.
In terms of the self-improvement and protection, it's the same as almost all the other issues that we've discussed pretty much since the very first episode, which is that movement is in the very beginning of our evolutionary history.
The diet and exercise need to go together. They've always gone together. And if they don't go together, something falls apart. So we evolved the way we move to get the food we eat. And if we don't eat the right food and we don't move the right way, our bodies fall apart and are programmed to fall apart faster than most other animals because we need to stay as efficient as possible to feed this giant brain while using no energy. I know, it's like we're cursed.
It's fascinating though, the iterations at whatever level you look at it, the proper diet and being active is just key to health just across the board whether you're looking at it from an early stage of life to the later stages or you're in the later stage of life. It doesn't matter.
It doesn't matter. No, the same things we need when you're young, you still need when you're old. And the same things that go wrong when you're young go wrong when you're old. However, it is really important to think about your future and exercise now for how you're going to be later.
Yeah.
And again, this doesn't matter what stage of life. If you're in puberty, you should be thinking about menopause, which is unimaginable during puberty. But if you're 50 years old, you should be thinking about your mid-60s, right? You need to be thinking about how am I going to maintain this bone density longer in life for as long as possible.
The ending is in the beginning. Start up the way you mean to keep up. That's,
absolutely.
Yeah. Fascinating.
Well, thanks, Eric.
Thank you, Josh. All right, folks. Until next time.